high level. Yeah.
This happens for every query that is issued.
In the detection phase is supposed to happen for every query, and there again the question of performance comes into picture. How is going to affect that? But unfortunately, this is not, the system is not there yet, where I can give you some answer on that. But of course, that's a very big concern. So what are the detection tasks we are looking at? So I have identified 3 kind of anomalies that you can have in the database system. You can try to detect anomalous access patterns. A particular application or the user only accesses certain portions of the database. Now I'm assuming here that the principle of least privilege is not there in the first place yet, that the user has more privileges than he requires to carry out his normal tasks, and which is, trust me, is very much the case in real systems. So you want to see, normally he accesses this particular portions of database, and when for a new query, if the access performed by a new query is in let's say in harmony with his previous accesses. Otherwise, it's termed as anomalous. So, but I'm not going into detail of this anomalous access pattern system. Then SQL injection, as I described. So that's again, you can model that as an anomaly detection problem. Then there is again something called as query flood attacks, where an insider floods the database with a lot of queries and leading to denial of service for other legitimate users. So this problem can also be formulated as an anomaly detection problem. But what I'm going to speak in little bit in more detail in this presentation is about an anomaly response mechanism. Okay. Now, what are the problems with a response system? Let's say. So you have a user, submits a request, detection mechanism, okay, detects that it's an anomaly. Now, what are the response options available for, let's say, the response mechanism? It can log the request and that's it. It can send an alert. I'm not sure if it's that visible, but that this particular thing is sending an alert to the administrator. And typically these two are the most popular response actions. Or if you go further in context of database system, you can revoke the access of immediately revoke the access of the user. You can abort the current transaction. So the key question is which response option to choose. Some of them are kind of benign. You send an alert, you log. Some of them are aggressive. So the question is which response option to choose. That's a very difficult problem. We are trying to address this problem by using a policy-driven response engine. And some of the details will come up in later slides. And the second problem with the response mechanism to date is, so you have response options which I just show you. Some of them are aggressive, like abort the request. Deny is you deny the privileges to the users, which you think are anomalous, or you revoke those privileges. So I'm not going to the semantics of deny and revoke here, but there are 2 different responses you can take. Or you can just disconnect the user session. So all these are very aggressive response actions because they are going to interrupt the user query. Or you can be very conservative and you can simply log, or you can send an alert to the administrator. The problem is, can we do better than of being very aggressive and being very conservative? And we address this problem by introducing the notion of fine-grained response actions using the concept of privileged state transitions. Okay, so much far. So what is a privileged state I'm talking about? So we propose that a privilege assigned to a user or a role in the database can have a state associated with it. If you want to think about it, right now you can think about a privilege can be in a binary state. Either it is assigned to a user or not assigned. So we say, okay, you can have more states assigned to a privilege, assigned to a user. So these are this is the state transition diagrams that we present in this work. Let me just explain it a little bit. So you start with a privilege. If it's assigned to a user initially, the state is clean. If So I think in the later slide present what is meant by privilege suspension and privilege tainting. Okay, so let me go to that slide first actually. So what I mean by privilege tainting, so you can go to the tainted privilege state from clean, right? So let's just first see what you mean by privilege tainting. It's a very simple concept. The request still goes through. If you mark a privilege as tainted, the request just goes through, but so it essentially means that the detection engine does not have too much confidence in the anomalous request, in the anomaly that it has detected. So the response, and that has to be conveyed to the response engine in terms of, let's say, a confidence parameter of the anomaly assessment. So the response engine, you can have users can define a policy to mark the anomalous privilege in question as tainted, and now the tainted privilege state can be used to for other policies to specify more stronger response actions. Like for example, if you see that a lot of privileges are getting tainted, so you can have a policy which will show later what policy looks like. You can have a policy which will say, okay, now the privilege should be revoked or denied. So that's a less severe form of response action which can be built upon by which can be used by more stronger response actions. Then there is again something called as privilege suspension, which is a little bit more stronger than privilege tainting. So you suspend a privilege which is so the request is blocked unless a confirmation action is performed by the user. So you put the privilege in suspended state, or assume that if a user request comes and the privileges that it is asking for are in suspended state. So what's going to happen is the system is going to ask the user for a confirmation action such as re-authentication or a second factor of authentication. This can be guided through a policy mechanism, and if the user passes that confirmation step, then further actions can be taken. If it fails, then stronger action can be taken. If it passes that thing, then the request can be allowed to go through and the privilege can be moved back to the clean state. Okay. So I guess this is what I have to say about privilege suspension and privilege tainting. And once you specify state for privileges, it's going to introduce complexities in the working of the access control mechanism. So you can build upon this work upon how to have a nice access control, a formal model of an access control system which incorporates the notion of privilege states. Okay, so now I'm going to talk about when a detection mechanism detects an anomaly, it's going to submit an anomaly assessment to the response mechanism. So how what is the anomaly assessment going to look like? So it's going to submit the anomaly assessment in terms of two kind of attributes. One is contextual, another is structural. And what I mean by contextual anomaly attributes are they describe the context surrounding a particular user request, such as the user executing the request, the role or the roles is associated with that user at that particular time, the source from where the request is coming, and so forth. And the structure is the actual structure of the request. So which database it is accessing, in that which schema it is trying to access, what are the objects like tables, views, stored procedure, what the request is doing, and the attributes, again, they will differ depending upon the objects that are accessed, and then again what SQL command was used in the request. So these anomaly attributes kind of act like an interface between the detection mechanism and the response mechanism. And when we talk about a response policy, we are going to define a policy based on these attributes itself. So we're going to just look like in the next couple of slides what a policy language looks like. So it's a event, condition, action kind of a policy. An event here is an anomaly detection event in the system. And if some conditions are satisfied, and what I mean by condition is one particular condition is an atomic predicate defined on